Now there's a short list of things here that you have to totally understand if you're going to do well in this course. And the first thing that you need to understand, when we talk about velocity, that's a vector, acceleration's a vector, a position vector, obviously by its name would be a vector. And from time to time we add these vectors. And so if I have a vector here that I call vector A, and then I have another vector here that I call vector B, like that. So I got vector A, I got vector B. And if I want to add those two vectors together, one way that you can do that is called the parallelogram law. So you got a line here that is vector B, and so you come parallel to that line and you dot in another line, and then you take a line right here and you go parallel to it. So this line is parallel to this line is parallel to this, and you see that forms what we call a parallelogram. And if I go from this point then to this point like that, then this right here would be the vector. We could call it C if we would like, and we could say that that's equal to the vector A plus the vector B. Now that's pretty simple. How do you do it though? Well, I'm not here to teach you trigonometry, and really you should already kind of know how to do this, but if you're going to work a problem this way, you're probably going to have to go look up the law of sines and maybe the law of cosines. You're going to have to kind of get to be friends with those guys, and then ultimately you're probably going to go, whoa, it's a parallelogram all right, but what I'm really looking at is a triangle. And so maybe I should be thinking triangles. And so what's the sum of the interior angles on a triangle? It's 180 degrees. So I'm going to have to give you some help, and I'm going to have to tell you the angle of this vector and its magnitude, and that. I mean, you're going to have to know some things, and then you're going to use what you know about the law of sines and the law of cosines, and you'll be able to get the length of that triangular side. So if you have any hesitancy about how this parallelogram law works, you need to start thinking about that. And as we move into chapter 2, I'll go a little bit more in depth. But the way that we mostly do in this class is we work with orthogonal coordinates, and x, y, z is the way we normally do it. And using those coordinate systems, we would say that vector A has a certain projection in what we call the I direction, plus a certain projection in what we would call the J direction, plus a certain projection in the K direction. So X and I are interrelated, Y and J are interrelated, Z and K are interrelated. And so what they really are these little unit vectors that point in this direction like this. And I think what I'm telling you here is almost totally review, and you might even argue that it's not worth our effort to talk about this, which is the reason I'm talking really fast about it. But I'm just trying to jog your memory. And if you don't understand something I'm saying, you're going to have to dig around or come ask me a question or something. Okay, so I take the two vectors, break them into their x, y, and z components. Those are called orthogonal components. And then I can say that my vector C is equal to AX plus BX in the I direction, plus AY plus BY in the J direction, plus AZ plus BZ in the K direction here. Now the advantage over this orthogonal, I'll draw a little line right there to kind of separate us. The advantage of using this approach over this approach is, with this approach, I have to go two forces at a time. With this approach, if I had a C vector and a D vector, I could just take each one of those vectors, write them out as their individual components, slam everybody into the same addition, and I could add as many vectors as I wished. So you have to get to be comfortable here. Now, we're going to spend a good amount of time in chapter 2 getting comfortable, so I'm not asking you to go completely relearn this on your own. I'm just giving you a heads up about where we're going. So familiarize yourself with this as best you can. When we get to chapter 2, we'll hammer on it enough until I feel like that you probably should know it.